I think in the science world, I don't know, I feel like I've almost got depressed about this. I don't know about you, Vicky, but it's just so predominant science misinformation these days. It feels like we're just constantly going on an uphill battle as scientists. Like we're not taught how to do communication stuff, and then everyone out there, you can put a 5-second video to say anything.
Hi everyone, welcome to episode 3 of Reforming Academia. I'm Victoria.
I'm Chloe.
And let's get this started.
Okay, cool. So our topic that we were chatting about just before we pressed record on this, that we want to chat about today, is science misinformation. I mean, this has been a conversation in science world for years, but I think it's finally making it into the public sphere because, people are starting to realize that a lot of what people are saying on social media, you can't necessarily trust unless they have the expertise to back it up. And I think in the science world, I don't know, I feel like I've almost got depressed about this. I don't know about you, Vicky, but it's just so predominant science misinformation these days. It feels like we're just constantly going on an uphill battle as scientists. Like we're not taught how to do communication stuff, and then everyone out there, you can put a 5-second video to say anything.
I agree on that. And last semester when I was teaching a course, I specifically spent a lot of time talking to students about misinformation online because it was a course to somewhat of an introduction course. So it's not for science majors. It was actually all my students except one student. We're all non-science majors, so they had really little science background. And I spend a lot of time with them talking about how do you distinguish between misinformation and not? What are actual sources that you can trust? What are sources you cannot trust? And you'll be surprised how much students just don't know. And these are already college students, and they don't know how to distinguish between what's a legit source and what's not a legit source. What do scientists actually do? How does scientific papers get published? What goes into research? They know actually very little about anything related to science. And now thinking about that, so if you're not a science major, you really don't know anything about science and what goes on in the research world.
That's why I always say to anyone that's doing college, even if you're not a science major at all, that you should do a semester or summer internship or something in the lab. Because I talk about this a lot, is during high school, I didn't care about science, and then it was when I got to work in a lab and I saw how the research process worked, that's what excited me into the scientific world. And even if you work in a lab and you're like, oh no, I hate research, getting that experience to see how new discoveries are made in real time, I think it helps people realize exactly what we've been, you can yell it from the rooftops as much as you want, but I think that hands-on experiential learning can mean so much. And going back to what you were mentioning about people don't know how to discern between a real source and a fake source. And of course, you've got all of us, I've even caught myself in this before, saying, yeah, everyone should know how to do this. It's obvious, just do some training or whatever. But those trainings really aren't out there. That's awesome that you were teaching a class about it, but I assumed this was an elective course and not a required course.
It was a required course,
Oh,
but
good.
I set it up in a way that I spent a lot of time. It was not necessary to talk to them about scientific research, but I tried to talk to them about real world. So with every topic that we covered in class, I tried to relate it back into the real world and how those discoveries were made. We talked about breast cancer, and I talked about breast cancer research. We talked about antibiotics. We talked about antibiotic resistance. I mentioned vaccines, which I tried not to go too in depth on vaccines, just not trying to get canceled. So
Isn't it? Sorry, just to pause on that for a sec, I was told by someone that they had to stop talking about vaccine research because every time they did, they'd get censored on social media. And we're not even talking about, I don't know if I want to say it, but the 2020 pandemic stuff. Even the vaccine issues happening now in present day, there's so much, one, misinformation, but then two, the real scientific news seems to get censored and not do as well.
Yeah, for example, even for the antibiotics, when I had the lecture on antibiotics, I tried to tell students about the research that goes into antibiotics and how hard it is to find any new antibiotics and why it's so important to pay attention to that you're not just taking antibiotics for a random flu. And you'll be surprised how many students didn't even know that you're not supposed to take antibiotics for a flu. We get very little science education in primary school. So going into college, unless you are taking a science course like a biology. Even I know usually in college they require for you to take some courses that are outside of your major, but some students might want to take astronomy, so they don't need to have anything related to biology, or some other course that they just don't expand their scientific knowledge, and then they go on living the rest of their life only knowing very basic that mitochondria is a powerhouse of the cell.
No, but I almost think when you get to the college point, that's too late to get a lot of people interested in science, because by that point, a lot of your ideas, assertions are ingrained. And exactly what you said is, even when you're talking, oh, I need to take a science course, it could be anything. It could be archaeology, it could be astronomy. It's not necessarily the nuts and bolts of how the scientific world works, right? And that actually goes into something that I feel like I've been preaching about a lot, but more recently, I'm going to have to find her name and tag her or something, because there's this PhD scientist, she's a couple decades got her PhD before us, and she went into the science education space of like the K through 12 academic sphere, so the young pre-18s. With the exact reasoning of, by the time you get to college and are trying to get people interested in science, it's probably too late. And we aren't giving people a good science education in those younger years. And there's always that talk of like, okay, you'll learn science in middle school a little bit, then you take some specific classes in high school. But why aren't we teaching it when we're teaching people, I don't know, how to read and write, even in elementary school? Like, say you're teaching the periodic table and you're teaching the basics of chemistry, or what's carbon, hydrogen. To be frank, it's the same as learning any other language, right? Like learning English when you're in first to second grade. So why can't we apply those same teaching principles of how you teach English or how you teach history, just the same things that we do for science, and make it fun and accessible? One of the ways I think to make science more fun and accessible is humanizing it. Like, you were talking about all the cool science research happening, like breast cancer and CRISPR and all these really exciting things. But oftentimes they feel like, okay, they're just like these topics out in the ether, and if I, get cancer, or if I have some sort of illness, then I'll start worrying about all of that. But what about learning about it from more of the people aspect of these really cool people? They were just like you and I, and they spent half their life researching about this new drug or this new vaccine. Humanizing the science. I think that's what we need to be doing more to combat science misinformation.
I agree, which is how the course was set up when I taught last semester. Is usually was a topic, and it was related to, for example, I talked in the class about cystic fibrosis, I talked about breast cancer and genetic testing. We talked about antibiotic resistance, talked about evolution and some of the discoveries, and we tried to relate it to a topic so the students would get more engaged and more involved. How I actually got interested in science was in middle school, and my science teacher would bring a lot of like cool science toys to play in the classroom, and that was a way she would try to get us more engaged, and she would explain some of the laws of like physics and chemistry through playing with some toys, which I went to underprivileged middle schools, but that was a way she was trying to get us engaged with learning science.
Yeah, and so much of science learning is hands-on. Like, I used to think of kind of why I didn't like science in middle school, high school, is I thought of it as all these dry textbooks, multiple choice tests. You see a bunch, to be frank, you see a bunch of old white men in their lab coats or their suits in these textbooks. You're like, oh, okay, like, it's all been done. And then when you actually get to step foot in a lab and you see, one, what sorts of different people work in those lab environments, but two, how the discoveries actually happen, which is a lot of passion, a lot of dedication, and then, sometimes you throw in a bit of luck mixed in there. I think it makes it much more exciting and fast-paced. And maybe we should transition then into talking about our experiences with maybe science misinformation, trying to combat it, or the problems that we learned picking up in academia and grad school specifically.
Yeah, sure.
My thoughts about grad school and how I learnt both about misinformation, but I think how academia's current approach to misinformation is misguided and outdated, is you've got the elite ivory tower of academics, the professors, the tenure track system. And I think for the past 20 plus years, and this is not exclusive to academia, I'd say it's also been a problem in industry as well, and government, is when problems come up, or someone's like, oh my gosh, that gene therapy killed a kid, or did something really drastic and really bad. And rightly so, the whole public's up in arms, being like, this is terrible, we can't let this happen, where are the checks and balances? But the response from the scientific community isn't to try to meet people where they're at. It was to like cocoon themselves and be like, okay, that's why we need to protect the scientific integrity, keep it all locked away behind paywall journals, because only the true elite can understand scientific papers. But by creating and fostering that sort of system, when, say, you and I got to grad school, it was tough to break into the field of even like when you're learning about, say, my PhD topic. I remember I didn't really understand my lab's whole field until maybe my second or third year of my PhD, because I was reading all the scientific papers that we'd published in the field, but they were so full of jargon and acronyms and like my lab specifically, we changed the term of the amyloid we'd been studying like 3 times throughout the past 10 years. And only if you knew that we changed that terminology, there was no paper explaining, oh, we've changed this to this to this. It's just you had to kind of know it. And that meant that only, 5, 10 people in the field could understand and follow this research when we changed the amyloid's name. And how are you meant to expect the public to understand that stuff? The traditional academic thinking and how I see it, and how I was trained into the system, is you should use more of that jargon and terminology, because if it's harder for the public to understand, then it's only one of us that can really be able to communicate to the public, rather than, say, what I think science should be, is any layperson on the street, John, Dick, Harry, should in theory be able to pick up a Nature, a Cell, a science paper, and understand what it says without having to read 20 other papers along with it.
I totally agree with you, and I think a lot of the science miscommunication happens is because scientists are never taught how to communicate science. Like I mentioned in one of the podcasts, that I took a science communication course and tried to learn how to break down science, but most of the professors cannot explain their research in simple terms. And how do you expect to get anyone's attention or interest in your work if you can't try to catch someone's attention? Because
Well,
we live in
that's the
a,
problem.
yeah. I think that even as I teach my classes this semester, I try to break down all the materials into simple terms and start off with the basics and transition into more complex topics. And I'm trying to come up with a curriculum where the students learn all these terminologies, right? And half of the class, a little bit more than half of a class, we will talk about those vocabulary and why it's essential and what they're used for. And then I'm trying to give them like a problem solving question where they will get to apply those scientific terminology into like a real problem. Like I will give them maybe like something food related or medicine related, and just to get them thinking about being able to explain the problem using this terminology and breaking it down. Because what I found teaching now courses is that the students are pretty much with science is just memorize, but they don't understand how this applies into the real world. Because when I give them extended questions, it's been like, explain how this works, like explain why frame shift mutation is more severe than the other mutations. They can't do it because they just memorized what frame shift mutation is, but they don't understand what it is. And that is the problem. And this is what leads to scientific miscommunication, is because even people that major in science, their whole scientific career, they're just taught to memorize concepts. They never truly understand what some of the scientific vocabularies actually mean.
And it is exactly why I say that every scientist should be required to take a communications course. And I've probably said this also in a previous episode, but like what I heard during my PhD when I started doing science communication is, and I quote, science communication is not for real scientists. It is for journalists, it's for the communications people. And for sure, they have their space and they're experts in what they do. But with how jargon-filled, dense, complicated science has become, and that, again, the fault of the academics, the industry, the fault of the scientists, but we've made it so complicated that, to be frank, the nuances and the implications can get lost on the broader audience, journalists and communicators. One fantastic example of this that's hit the news in the past couple months is microplastic research. So I don't know if you saw, like, the headlines, there are those catchy news things, the science articles coming out like, oh, we've got a plastic spoon's worth of plastic in our brains. And see them hit all the headlines and make these big deals, and there are other scientists in the field talking about this. But then if you actually dive into the research of the techniques that are being used, you realize that we're actually in really early stages. So not to say that we aren't consuming microplastics, I think we are. It's kind of that over-sensationalizing in the news of, okay, microplastic research, yes, we should probably be worried about over-consuming all these little plastics. But can you really believe that we've got a plastic spoon's worth of microplastics in our brain? No. And it's likely because, and this is if you dive into the research more, the studies done to figure out microplastics in the brain and like quantify that, we're at really early stages of that. Like the techniques we're using now are not going to be what the field are going to be using in 10, 20 years when they're researching this sort of stuff. I think goes back to this idea of needing the public to understand not just the science, but how science comes to be, the discovery process, the research process. Because if that was better understood, they'd realize why, I don't want to say scientists are going back on their word, but you find new knowledge and are constantly building on what you've seen before. So, for example, in 10 years from now, I for sure see that spoon worth of microplastic thing being extremely outdated. But instead of people coming back to the science world and be like, how dare you lie to us? It's like, no. You just need to understand how the scientific process works.
For example, in general, the public doesn't know how to break down a paper. Even if they open it, they'll just go read maybe the abstract or the conclusion, and it's going to be very like simplified, or it's going to be on the news and they're going to just be like all these headlights.
I need to ask you a question specifically based on this, that people read scientific papers without understanding, is someone who considers themselves a science communicator. And I was chatting with them. Not only did they not go to do science undergrad, or any sort of science in undergrad, they did English, I think it was. But they taught themselves how to read papers in a specific science topic. Again, no peer review, nothing. They just taught themselves during the pandemic, and now they have millions of followers. What is your thought? Like, can they consider themselves a science communicator?
That's a very good question. I mean, as long as you have some understanding of science, I feel like anyone should be able to read a good paper and understand it. That's what we're talking about, is anyone should be able to read a paper and understand it. And I was teaching my students how to break down a paper, even though none of them were science majors, so I think it's doable. But I personally think it's going to take a while for anyone to figure out how to break down a paper. Like, that was a part of my PhD. We had to do a paper critique. You have to understand what are the flaws of the paper. And that is very hard. That's the problem, because people can read the paper, but can you ask the right question? Is this a valid paper? What are the flaws of this paper? Not necessarily that the paper is bad, but what is missing from this specific paper? And like one of the things that I remember early in my PhD, I realized I was working on, had to read some papers about seizures. And all of the studies, I realized, were mainly males, like male mice. And I was like, how are we going to apply this to... I'm like, seizures don't only impact men. And they were like, oh yeah, they didn't want to use female mice because of the menstrual cycle, the biological clock of the mice. And now it's changing, and we know that female mice have to be included. But a lot of studies are published out there. We're just using male mice. There's an endometriosis study that was just done on men.
Stop it. I was just at the JPM for the biotech conference that they had there, and there was a women health research panel, awesome panel, and they were talking to me, say 1 in 10 women have endometriosis, and yet currently our biomarker for endometriosis is literally pain, which how do you measure that, right? But to the male and female mice thing, it was at this women's health research panel at JPM, but they were talking about how multiple studies that were doing early stage phases of clinical trials for some drugs that were going to get approved. And then they found out, when you actually dived into the data, I think it was 5 different drugs off to pull this exact research. It looked like the drug was helping patients, like when you looked at the clinical trial data, the aggregate. But if you split it by men and women, you actually saw that men were being approved by the drugs, but women was at the same, or if not lower. And it went back down to, they were talking about like hormone cycles and not understanding all. It's like, okay, yeah, we don't understand it, but we have the tools to be able to do that. Just do them on women now, not just men. Crazy, right? 2026, and that's still the conversation we're having.
Yeah, which, right, how you're taking it back to talking about scientific research. Can you actually distinguish if the study is done right? Like, can you catch that? Can you catch if the study used only males, only females? How many? What was the size of the population? Did they look at the sex differences in that specific study? Because yes, females and men are different biologically. Like, we know this, and we know that there's differences in diseases. We need to account for that when it comes to studies. What was the sample size? Was there like 20 people, or was there 2,000 people done in the study? Like, I think we need to talk more about that out in the public, and I think the scientists need to be able to communicate not just how great their research is, but the limitations of their research. What can they do and what they cannot do? What does technology allow them to do and what it does not allow them to do? It's not because the science is bad, it's just we haven't gotten there yet. The technology is improving and eventually we will. And I had to make an emphasis to my students last semester where I was like, well, the technology improves. It doesn't necessarily mean that at that time that the scientists were wrong. This is just the only thing that was accessible to them at that time.
And for all of the flaws or faults that you can get into academia, one of the fundamental amazing things about a PhD program, and to some extent a master's program as well, is it is built in how to not just do science, but rigorously think, analyze, understand, and critique science. Because we all just think, yeah, anyone could pick up a scientific paper. And in the dream world, I agree, in the ideal future, anyone should be able to pick up a science paper and understand what's going on. Right now, it's hard to understand if you have to dive into the results to see, oh, they actually only use a sample size of, I don't know, 3. Hopefully they use way more than 3. But there are studies out there that are published like that. Or same going back to that microplastic research I was talking about. If you dived into the research and the data, you'd realize that it's early stages for the technologies that they're using. And again, exactly what you said. It isn't necessarily that scientists are doing bad science. It's just the tools that are available in this moment and understanding how tools can advance.
Yeah, which also, just to mention as an example, a lot of the times you will see headlines like, this drug cures all cancers, and then you look at the study and it's just done on cancer cells in the lab. And I'm just like, we're not even close. We're in like the earliest of the earliest possible stages.
And I feel like scientists, we've shot ourselves in the foot for the longest time. Like the academics, the government, the industry, because of that, we keep everything, we gatekeep it. Because we're like, oh, well, only these certain elites will understand it. But by doing that, we perpetuate the scientific misinformation and distrust, leading to other people that aren't in the science sphere thinking that they should go online talking about it. I mean, one of the greatest examples, or greatest, worst examples, is all this skincare, makeup, beauty trends right now. And you'll have absolutely anyone saying, like, this is the best thing you need for your skin, or collagen's going to sink through. If you look into the research behind of it, like, no, it's not. What are you talking about?
Especially became highlighted during COVID with so much misinformation online. And even when scientists tried to talk, they didn't know how to communicate it well to the public. And I think there was a lot of mistrust for the scientists. And because we get bunched in with pharma, even though those of us that were in academic research were not even close to pharma.
I relate to this one a ton. So the person commented saying, I graduated in July last year, but I still feel exhausted. I'm also angry at myself for letting a degree define my life for so much more than 3 years. I am glad I'm on the other side of it now, but I still have anxiety issues, especially when working in the lab. I love my job, but I'm also scared it'll get horrible as my PhD time was eventually. Dang, I relate to that hard. I don't know about you. I think I'm just recovering and getting on the other side of my burnout, and I left the lab in 2023, 3 years ago.
I mean, I took a couple of months off after PhD. Then I went straight into postdoc, and I feel like I was just so burned out from my PhD that it was so hard to transition into the postdoc and a role of a postdoc. And then when I left the postdoc, I was like, I spent the summer not working. And it was the best time of my life. I was like, oh, wow. I was like, I'm going back to the before grad school me, which is so hard. I felt like grad school defined so much of my life for so long that finding hobbies, like going back to what I like to do, like running, exercising, reading, traveling, all of those things were just so hindered by grad school. And I felt like I let grad school define me so much that it became my only personality and that's who I was, that now I'm kind of finding myself outside of that sphere, that I am still a scientist, I'm an educator, but I am a person outside of that.
That's such, I think that's exactly what I was struggling with, is the focus of your identity for so long being this PhD student, this scientist. And I do think relatively I still had hobbies and I was able to do social stuff relatively during grad school. And I thought I'd set myself up well for success afterwards, whatever that means. But then on the other side of what you said is losing that identity, because especially I left my PhD and went straight into patent law. So no longer working at a bench, no longer, I mean, I was working with other scientists, but they were not academic researchers, they weren't in industry. And that for a long time, I almost changed my handle actually. I don't know if you remember this when I put up my private story of giving alternative names that I changed my Instagram to. So like I was getting hate, not a ton, but people were like, you're not in academia anymore, you can't call yourself a scientist. And I really internalized that for a long time. That my worth was defined, say in academia, your worth is defined by your publications, by how much your scientific output is, how many experiments you're able to cram in a day. And not having those standards anymore defining your life on the other side. I completely relate to this girl saying that she's still got anxiety and like the thinking about certain times in the lab bring up that anxiety again, because that's something, I mean, again, just coming out on the other side of it, but for 2 years, essentially even opening my laptop or hearing like the Outlook ping just brought me back into my last year of my PhD and the hellhole that I was in. And it's so interesting, those little cues that really make you spiral again. This isn't really related to science misinformation at all, but I think it's a really important conversation to have.
I think until today, like, it's now I'm no longer defined by the data I produce or by the work I do in the lab, which is so freeing at times. I loved being in the lab. I'm not gonna say that I had like a bad experience. I liked doing research and I liked being in a research setting, but it can be a lot. But talking about endometriosis, I had endometriosis all through grad school, and that was so hard trying to manage my health, but at the same time, working crazy hours, knowing that that's probably also contributing to my symptoms of endometriosis, of being overworked, super stressed, which are not helpful when you have already a disease that's heavily associated with inflammation and you're chronically stressed and overworked. Not the best combination. So now I feel like I can actually manage my health much better. Not gonna say that I'm just chilling at home all day. Actually, I was working until like 7 p.m. trying to come up with lectures for students. But it is based on my terms. I don't have someone critiquing my data or how well I did the experiment. It's more on how well I can communicate something, and I am my own judge at this point, and my students, obviously, but it's not as stressful, I would say.
Yeah, and I think that's inherently one of the problems with grad school is you can't do it all. We're expected to do it all, volunteer for everything, do all the lab work, do all the presentations, the publications, and then somehow, actually tying this well back into science misinformation as the topic, somehow we're also meant to learn how to communicate and talk about our science to people, not just beyond the lab, but beyond the department, beyond your university, to, your mum, your dad, your friends that aren't in science. And that is like stepping back outside of academia, that is a crazy expectation to have of people, especially when you aren't providing them any of those tools. You're literally just throwing someone that maybe you've just done undergrad, like me, I worked in labs part-time, but that was my first full-time, oops, sorry. Cat woke up. That was my
Oh, that's a nice addition.
Yeah, nice addition. You want to say hi, Bella? She's so sleepy. I lost my train of thought now because we saw a cute cat. Oh, just the expectation of grad students needing to learn everything and do everything, but without being given the tools and support to do that. And maybe that's like the take-home message from this episode with science misinformation is more scientists should be learning how to communicate to a larger audience, but the burden shouldn't just be on the students, it's also on the institutions to provide classes like Vicky, the class that you were teaching, that everyone should learn the fundamentals of what a scientific paper is, thinking and analyzing information, because that goes beyond just like a scientific research paper, but to be frank, all the news that's out there today, science and beyond.
The distinction between now, I mentioned in one of the episodes, there are now academic faculty, more like the ones that are there to teach, and research faculty, right? Becomes an issue when you have research faculty that don't know how to teach because they don't know how to communicate science well. And how do you expect for them to teach it if you never provide them pedagogical training on teaching and how to talking about science? Do you know anyone has gotten pedagogical training during their PhD? No, but that's something that should be included in your PhD. You should be able to teach someone science, but it could be one of the courses. It could be one of the elective courses through the PhD. You should be at least available to students to learn if they want to learn.
Precisely. And without being, because the part I was going to add on there is the only people in grad school that learn how to teach is because they're forced to do so for the most part by their lab that, oh, we don't have enough funding, or you might be a department requirement, but essentially it's extra free labor that you need to give in addition to all of the lab work and publications and everything else that goes on top of being a grad student.
Yeah, like I had elective courses I could have taken in grad school, and if there was like a scientific pedagogical course, that would have been interesting to take. No, but we had to take like courses like talking about other research papers, and I'm like, you already do that in your own lab, reading papers and talking about papers. You're not getting much information out of it anyway, but that would be like a useful course to take.
This is making me think, maybe it's down the line, we should do like a journal club where we just like talk about cool science papers and like how we'd go about reading them. So there's food for thought for the future. Cool. Well, on those amazing bombshells, we will see you guys next time. Thanks for tuning in. We are Reforming Academia, your hosts, Chloe and Vicky.
Bye, guys.
Science is for everyone.